Hello students, this question is from test series 6, subject fluid mechanics and chapter fluid dynamics, and it is of 2 marks. The question says, a tank and trough are placed on a trolley as shown. Water issues from a tank through a 5 cm nozzle at 5 meter per second and strikes the trough, which turns it by 45 degree as shown. Then the compression of the spring of stiffness 20 Newton per centimeter is option A 2.09 centimeter, option B 1.74 centimeter, option C 3.67 centimeter, and option D 1.9 centimeter. Given the diameter is 0.05 meter, velocity is 5 meter per second, and the angle through which the water is turned by the trough is 45 degree, and the stiffness of the spring is 20 Newton per centimeter. We have to find the compression in the spring. Now compression is given by Rx by K, where Rx is the force and K is the stiffness of the spring, where force is given by m dot into velocity. Here m dot into u2, because u1 is 0, as the spring will have only axial displacement, therefore u1 will be 0, only u2. So where the mass flow rate of the water will be density area into velocity, and the velocity u2 will be u cos alpha. So to find x, we have to find Rx and Rx. So m dot, that is the mass flow rate, will be rho au. Density is 10 power 3 kg per meter cube, and the area is given by pi by 4 d square. We know the velocity, diameter and the density, so we can find m dot as 9.82 kg per second, and velocity u2 will be u cos alpha. We know the value of u and alpha. By substituting this, we will get the value of u2 as 3.54 meter per second. Therefore the force in the spring will be m dot into u2, which will be 34.7 Newton. So we can calculate the compression in the spring, which is x is equal to the ratio of the force and the stiffness, which will result in 1.735 centimeter, which is our required answer, which will be option B. So B is the correct answer. From this we have learned how to find the compression in the spring by calculating the force in the spring. Thank you.